Hello everyone, today we'll be going through this chapter 13 on electrical systems. Okay, so please have your 13A notes with you. I have given it out during your post-exam activity and you should be having it with you physically right now as we go through this chapter. Okay, so for the introduction, we'll be giving you a few circuit components to learn and also to learn how to draw them, okay, so that you can actually draw a circuit diagram with the correct and accurate drawings to represent certain items inside a typical circuit. All right. Now, what is electricity? Okay, so electrical energy is also known as electricity, and it is an important form of energy. All right. Now, a lot of times we use all these appliances at home, and they actually function by converting this electrical energy into various forms of energy. Okay, so take for example a kettle or an iron, right? We have to plug it into a socket, and from the socket we actually have derived electrical energy, and it is being converted, right? Remember your principle or the law of conservation of energy. Energy can be converted from one form to another, right? Or from one type to another. Okay, so this is something that you've learned before, the principle or the law of conservation of energy, right? So take for example the kettle will convert your electrical energy into thermal energy for water to boil, and for electric fan it will convert electrical energy into kinetic energy. As for the iron, it works the same way as an electric kettle, whereby it will convert electrical energy into thermal energy or heat energy. Okay, so when we look at a circuit diagram, okay, we are basically just copying and pasting a real electrical circuit, okay, into a circuit diagram. Okay, so electricity will flow and will be delivered to an electrical appliance from a power source, and this is actually conducted via electrical wires, right? So the setup is called electrical circuit, and okay, for simplicity's sake, okay, scientists prefer to use simplified and straight to the point diagrams known as circuit diagrams to represent electric circuits. Okay, so we see over here that the battery now looks like this, okay, or the cell, electrical cell, okay, and the light bulb looks like this. All right, now, so let's take a look at some of the circuit components. Okay, now one cell, okay, means one battery. Okay, if we talk about singular, and plural. Okay, so if we are just talking about one, what we call in layman terms battery, right? It's called a cell, okay, and two will be called a battery. All right. Now, a lot of times we use our devices and we use our electrical toys and all that, and appliances, and we need to use two, right? So it really depends on the voltage that is needed, right? So later we'll be covering about voltage, but just know that if I'm talking about just one over here, okay, it's called a cell, and if I have more than one, it's called a battery. All right, and most of the time it comes in pairs lah. All right, so let's see how do we draw them. Now it's a very simple long and short line, but take a look at the terminals. Okay, you are required to label your terminals as well. So the one that pops out here will be your positive terminal. So please annotate it with a long line, and the minus, or rather the negative terminal, will be the shorter line. Okay. Now in electrical components, sometimes we will use a switch. Now this switch has the ability to allow the current to flow or to stop the current from flowing, right? Now, so a switch typically looks like this, okay, in reality. But when we draw it, okay, let's just draw two small circles. And if it's an open switch, it will come up like that. Okay, if it's a closed switch, then it will look something like this. So this is a closed switch. Now a closed switch will definitely be able to allow electrical energy, right, current to flow through. Okay, so that's what we have here, a closed switch. Okay. Now, what about wires? A lot of times we need to connect these components with wires. So in this case, wires, if they are not joined, they will look like this. Okay. Whereas if we have wires that are joined together, okay, we will annotate, or rather we will show that it is being joined up and connected via this intersection over here. Okay, and this also allows the current to flow through. Okay, light bulb. Light bulb is seen like this. Okay, a circle with a cross. Okay, now a fixed resistor. Later we'll be going through what is the function of a resistor. Okay, they come in two types. Okay, one is variable and one is fixed. Fixed means that the resistance that they pose is set and we cannot change. Okay, but for variable, right, there's actually a coil that allows for different amounts of resistance to be posed in the circuit. So the difference is actually the presence of this arrow over here. Okay, vertically drawn upwards. Now at any point of time, if you need to pause so that you can fill up your notes, please do so. Right. Now what is this fuse? Okay, fuse is actually a wire, copper wire, that's inside this casing over here. Okay, so in here is actually a copper wire. Now what's the purpose of this fuse, right? Now copper wire, a thin copper wire like this will melt if, let's say, there's too much current passing through. So when it melts, we say that it fuses, okay, and then the circuit will be open. Okay, so the fuse, as we will know later on, it will help to regulate, right, such that the current in a circuit will not be too much. If it's too much, then it will serve as a to stop it, okay, to break the flow of current, so that there will not be any chance of overheating or even an electrical fire, etc., etc. Okay, so we will draw okay, the copper wire, right, as a straight line inside this casement. Okay, ammeter, okay, and voltmeter, right? Very simply, a circle with an A and a circle with a V, okay, with wires that are with wires around, or rather on the left and right. Okay, so this is an actual circuit. Okay, so it's what we see in reality. Okay, what we actually see. And so this is a conversion, okay, into an electrical diagram. So do note that you see this part of the wire over here is represented over here, right? The pluses and the minuses also has to tally. Okay, so which terminal is facing which direction must tally. Okay, now you will never see a circuit that actually works if the pluses are together with the pluses, okay, or if the minus is together with the minus. So that is the wrong arrangement of batteries. So please do check when you draw, okay, that you have joined, or rather we have represented the diagram correctly. Okay, so this is a light bulb, okay, and you'll see these two light bulb being drawn in circuit diagram format. Okay, and this ammeter, okay, drawn in a circuit diagram format. So please convert accordingly. All right. Okay, next we see conversion of this particular actual diagram here. Okay, and this is converted, okay, accordingly. So really it's pretty much about copy and pasting and really replicate the direction of the flow of current as well. Okay, so these arrows over here, they actually show the flow of the current, which is from positive to negative. Okay, at this point here, okay, I want to go back to the very beginning. Okay, circuit diagram. Okay, so this requires drawing. So for every drawing, please remember, okay, that you will need to use pencil. All the lines, and it is involving a lot of lines for all the symbols, right? The lines needs to be drawn with a ruler, okay, and take note, okay, of the terminals of the batteries or the cell, okay, plus and minuses. Okay, so it should be neatly drawn with pencil and ruler. Okay, now we go on to the type of circuits. Okay, so a closed circuit, we will see that the switch is touching, is closed. So a closed circuit, what does it mean by having a closed circuit? Okay, it means that it provides a complete path without any gaps for electricity to flow. And with that complete path, the light bulb will light up. Okay, now on the other hand, if we have an open circuit, which means that the current has broken, okay, the current cannot flow anymore, right? Now this means that current will be prevented from flowing and the light bulb will not light up. So I will not show any lit light bulb over here. Okay, so this is what is meant by closed and open. Now the second type of circuits that we need to be aware about is either it's a series or a parallel. Now take for example your classroom light. Okay, the fact that you can control rows of lights with a single switch and not just one single switch to control every light in the classroom, okay, it means that it is of a parallel circuit. Okay, now what does it mean by having one switch to just control just one row of light? It means that if we talk about the pathways for electricity to flow, there's definitely more than one pathway. Okay, this is called the parallel arrangement. Why do we call it parallel? Look at these two lines. They are running parallel to each other. Okay, so current will be able to flow in two or more pathways. Now let's take a look at the series circuit. Okay, now you can see that, hey, it goes only in one direction. All right, so it's only the components are connected one after another in a single path. Okay, so please take note of the keywords. Okay, series will be single path and parallel will be two or more pathways. We call it pathways. All right. Okay, we will stop here for the time being. Please make sure that your notes are completely filled up. Okay, the questions in this SLS package is also answered to completion. Okay, and we will see each other in term 3. Thank you very much.